Yes, you have to get the big one.
Good afternoon and welcome to ITI and INCITS, the International Committee for IT Standards, which is the ANSI accredited SDO supported by ITI. Learn more about INCITS and ITI. ITI's website is itic.org and INCITS website is incits.org. I'm your host and moderator for today's roundtable discussion, the greatest challenges of cloud computing. We're hosting this roundtable because we are the conveners of the US delegation to the ISO IEC Committee for Cloud Computing, also known as ISO IEC JTC1 SC38, Subcommittee 38 for Cloud Computing and Distributed Platforms. We have a very distinguished panel today, including John Messina, John Calhoon, Duminda, Wijesekera, and Jill Stellfox. I would also like to acknowledge the chair of SC of our Cloud Computing Committee, John Anderson of Hewlett Packard, and the INCITS Committee Manager for Cloud, Barbara Bennett. I would also offer a few brief thank yous for our event manager, events director for ITI, Christine Reck, without whom none of this would be possible. As well, Shavon Davis, Mia Harris, Jay Mahesh, Zam Munkjargal, Julia Moore, who all helped to support this event. A few housekeeping notes for the special room that you are now inside. There are microphones throughout this room, so none of us are wearing mics, but every potato chip and every cell phone beep is recorded for posterity's sake in this session. So you've been duly warned.
Recorded and amplified, no doubt.
And amplified. Thank you, Tommy. And our discussion is on the record, and it is. And unless otherwise noted specifically, everyone's comments will be considered to be their own views and not necessarily the views or the positions of their respective organizations. So you have some bios in the program, and the way that we will go about our dual hybrid meeting today, since we have a split audience and a split panel, we will introduce our remote participants first, starting with John Messina of NIST. And I will include something about the participant from their bio for the benefit of the people that don't have a copy of the bio in front of them. But panelists, as you're introduced, please feel free to expound upon your introduction and specifically share with us about your journey for participating in this amazing domain of information technology, cloud computing. So with that, I would like to introduce John Messina. John is a supervisory computer scientist and senior member of the Cloud Computing Project at NIST. He holds an MS in computer science and BS in physics. He's been working at NIST in the field of computer science since 1998. He has a distinguished record of scientific accomplishments, has received the Edward Bennett Rosa Award from NIST and the US Department of Commerce Bronze Medal. So as well, he is the vice chair of the committee that INCITS has in cloud computing. But John, before you really get into the subject matter, I want to ask you, how does it feel to be in the spotlight these days at NIST for so many years? I'm not suggesting that you have been slaving away in obscurity, but I mean to ask, how is it now that the spotlight is on standards? As a matter of fact, yesterday, your colleague, the head of NIST, Dr. Locascio was here in this very room, laying out the standards strategy for the US government. And she did mention in passing that it was a first to hear the president say the word standards. So, and those words are, of course, backed up by billions of dollars in new funding for your organization.
Well, it's kind of interesting being in the spotlight. I tend to be the person who tolls away in the background, making certain that the standards work. So it was interesting how I ended up working on the cloud computing program at NIST. If you go all the way back to December 9th of 2010, when Vivek Kundra established his cloud first policy, which really dictated how and why the US government agencies should switch to the cloud. That policy had a role for NIST, which was to help speed the adoption of cloud computing by the United States federal government. Interestingly enough, NIST was reorganized at that point, and I had been doing data exchange standards, dictionaries, and reference architectures for the semiconductor industry for quite a few years. And I got moved into our information technologies laboratory. And one of the first meetings I had in ITL was meeting with Dawn Leaf, who was in charge of the cloud program at NIST. And as we were going around the table, I explained what my skills were, and she just looked and pointed at me as like, "You're going to lead the reference architecture for cloud computing." And I was like, okay, which was sort of like, I wasn't given it a choice. It was like, you go ahead and do it, but I leapt at the opportunity. I knew that cloud computing was going to be huge over the years, and I definitely wanted to help guide both NIST and industry in that particular effort. NIST itself went on to do a number of efforts for the very basic level for cloud computing. We did a cloud computing reference architecture, which I helped with, a technology roadmap, which really identified 10 items that were holding back really wide scale rapid adoption of cloud computing. So we had a roadmap for us to use, a reference architecture, which really talked about the terminology and the vocabulary and the major components of cloud computing, which really helped bring everybody onto the same page, which was the major goal of those efforts. And then it ended up being used as a seed document for the ISO IEC SC38 International Standards on Cloud Computing. And because I had the expertise in the reference architecture and I'd led several of the public working groups, I ended up joining the effort, and I've been continuing on in SC38 for many years now, I guess 12 years. It's been quite a few years developing standards, and it's been a fun journey along the way. And I am excited about all our particular focus on standards moving forward. We still have a lot of standards to work on in the cloud computing area, and I'm looking forward to it.
Thank you. Thank you very much. If anyone asks you who is responsible for accelerating the US government's adoption of cloud computing, now we know the answer, that it was John Messina at NIST. Is John Calhoun with us?
Not yet, David, no.
Okay, well, I hope that John will be able to join us later. John is with Microsoft and is the international representative of the committee that we're talking about here with SC38. So with that, let's go to our in-panel, in-studio panelists, starting with Dr. because he has 2 PhDs, Dr. Wijesekera of George Mason University. And I'd also like to acknowledge that George Mason University is the very newest member of the executive board of INCITS, and we're so pleased to have an academic institution that is a first-tier organization. And perhaps before we get into the substance of the topic, I'd also like to ask you, how has your journey been on this rocket ship of George Mason University, which has quickly gone from, well, quickly over 40 years, it has gone from a commuter university to a first-tier research institution that there has been no single party to take so much research funding from the federal government, I think, since the days of Senator Byrd in West Virginia. But how has it been to be part of the development of George Mason that now covers 4 counties in Virginia?
I think it's a great journey. We have had a long and difficult journey at times. When I first joined the university in 1999, I was wondering what it was doing after I joined. But since then, the best way to describe that is like a well-maintained highway, always under construction, always getting better year by year, month by month. We've had successive administrations both at the state level and federal level, and also in the university itself, that have gone out of their way to make sure that we get the R1 status and we maintain it and go up that ladder for research. For engineering perspective, where I belong, we've gone from mostly IT-like engineering to really hands-on engineering that attracts a lot of Northern Virginians and other people to do real experiments. So I'm very glad to be here now.
Well, we're very glad to have you, and I also want to share with the audience some incredible highlights of your career. In addition to being involved as the chair of the cybersecurity engineering department at Mason, you are a fellow of NIST itself.
No, I'm not NIST. I worked at NIST for 15 years in the ITL itself, the Information Security Laboratory.
Okay.
I just finished that after 15 years. I also have other things to do, becoming the chair and running some of our large labs. I'm in charge of a large lab in Arlington, which some of you have seen. We are privileged to have co-located labs with industry, academia, and standards organizations such as yourself, where we seamlessly move between the academic side, the development side, the standardization side, and actual hands-on experimentation, which is what we are stressing with our new buildings that is coming up. We have one building that's an 8-story building where all of the labs, all the industries, everything will be co-located. We've been inviting local and state government, the federal government to come and work with us there. It's open space, there's no walls. You can move between different facilities. There's some industry that's participating here, namely Vitality. They are co-located with us.
And specific to cloud computing, I'm looking forward to what you bring to the conversation about cybersecurity and cloud computing and 5G communications and cloud computing, since those are the areas where you're making these contributions. And you have your 2 PhDs in computer science from Minnesota and PhD in mathematical logic from Cornell.
Yes. Am I supposed to expand on any of those things?
What do you see as the germane overlap with cloud infrastructure, which also is the road that keeps being built,
Yes.
like the university?
Absolutely. So cloud, when I first started working on it maybe 15 years ago, it was like we started with mainframes, then we went back to desktops, and then we went back to mainframes. That's what it looked like. And then the first generation had all the service architectures, like infrastructure as a service, PaaS and SaaS and so on, the buzzwords of that time, and the cybersecurity, the protocols, and the standards that came with them. XML did a lot of, XML had a lot of advantages, and it was easier to specify things, harder to implement them and enforce and audit and so on. Later on, so coming back from those days, we've now evolved, and all of the leading industries have gone to much more easier development platforms such as containerization, functions as a service, and all the big cloud providers are bringing them to bear on large problems. And one such significant problem is edge computing. where it's really close to the radio or other interfaces, which also enables the telecom companies to come in and use existing or enhanced cloud edge systems to do most things that we thought were done in very specific real-time computing, such as control systems that communicate using specific radio interfaces, applications to federal, both DoD, non-DoD, and even intelligence community requirements, including but not limited to cloud on the satellites, which we are talking about now. And spaceships, yes. All of them go with the expanding horizons. They bring security issues in the sense that the great background that we built in having secure processes and security standards for software needs to be vertically built to extend towards these existing new paradigms that industry is bringing forth. Almost every year we see a new paradigm, new toolkit, some commercial software, and also they do good by institutions like universities by having open source software, which our students have a great time using and doing their dissertations on, so that they are industry ready by the time they get over. And also connected to the great story of mobility with mobile systems moving around, mobile 5G systems that bring with them all the transportation, energy, and all the other management structures. With low orbit satellites, we will have another dimension, another set of requirements with different protocols. I know that one part of 5G is going for terahertz and millimeter wave communication for huge bandwidth locally. But on the other hand, if you want to go large distances, you need to lower your bandwidth. So with the open RAN architectures, it allows us to seamlessly manage things on the cloud, but the specifics of those software that are mounted on cloud or edge systems require the same degree, or if not less, but I think more aware of the application's consequences when you ensure that they could be not only implemented, be standards compliant, but also audited properly, have continuous monitoring into the interfaces that different devices provide on an open RAN, which is essentially edge mounted, and the edge connects to all of the other cloud services that are provided by large cloud storage systems that would become very application specific. The functionality provided by those things will be very specific, and they'll have different consequences depending on the application.
And that sounds like a perfect segue to introduce our last panelist, or second to last, if John will in fact join us. Jill Stellfox on the subject of low latency, high security, high reliability storage on the cloud and file systems. What an amazing journey you've had. Thank you so much for coming to Washington, DC to be with us. I understand that you're en route to the Marlins game to throw out the first pitch. In my homework, I've also learned that you're now part of the Inc. 5000. Congratulations.
Thank you.
3-year growth rate of how much?
483%.
Wow.
I'm exhausted. No.
I don't even know where to start with your background as a serial entrepreneur. You've helped so many people. I think in looking through the materials, I noticed that there is a tandem. You've had tandem recognition both for the growth of the company and as the people-focused CEO of the year. Are those two achievements intertwined?
they're not only intertwined for me, they're purposeful. We bought Panzura. So Panzura is a company that has been in the hybrid cloud space since 2008, just after the hypervisors started, right at AWS and Azure. And so we've been in this for a long, long time. I bought the company 2.5 years ago with some great investor friends of mine. And I set out to create a high growth company that did the right thing for customers, that also did the right thing for employees. Imagine we bought the company in May of 2020 in the height of COVID. And it's like, hey, I'm your new CEO. So it's a trying time for employees. And what we've proven is if we can take care of our employees, genuinely amazing care of our employees, we will grow more, we will make more profits, our customers are happier, all the financial metrics. And I want to prove both. So that's my goal. Create a lasting company where we do right by employees and everything else works out.
And how did Panzura get to be the lucky company that would be, getting your leadership and your new investment injection?
Yeah, so when we saw the company 2.5 years ago, they were doing business. In the government, we do business with DOJ. Every case file that the DOJ uses every day is on Panzura. We financial services, we do all the trading for people like Vanguard, all the wire transfers for folks like BNY Mellon. So highly regulated, really important data. And I looked at it from a data perspective, which is my history. It was a data logistics problem. I also went through all of the various phases of mainframe, desktop, we're doing mobile, now we're, and now we're cloud. The problem with cloud is cloud in real time with real users using real files is they make all the mistakes that a user would make, including creating an insecure environment by doing things that seem normal to them, clicking on the wrong email, all of these kinds of things. And so how do you create a world that is safe for data instead of making data safe? And it's just a different way to think about the problem. And so for us, we saw this platform that we could use to really create a space that was safe for data and easy to use for employees and just not noticeable. And we think we've done it. And I have a lot of great stories I could tell you about security breaches and all the other things that happened along the way. So.
Well, you also have 5 patents in this domain. Maybe that's what allowed you to recognize the great value.
Yeah, I came from this kind of environment of moving data super fast in real time in a super protected way. So, yeah. It's super fun though. We are doing a lot of work with satellites and space. And what's interesting is the requests from government versus private sector are very different. And the importance or maybe lack of experience is very different. The importance of security and lack of experience. But there are some very basic things that are not regulated today, like what does an air gap environment mean for when data explodes in, on a satellite or on the way, between a person just using a file in the field on their mobile device. Where do you stop a security risk? And that's not defined today. And it's left to however something is implemented. And so there's a lot of interesting things that we've both seen in real time. We have millions of users, lots of companies using this every day. And we've seen so many fascinating things where it's like, oh, it's not a standard. And it's left to companies like ours and others to create them. And therefore they're not the same. And this is sort of like fundamental stakes in a lot of perspective, right? So.
Well, let's bring John back into the conversation. John Messina. because you have some thoughts, I believe, about why organizations are turning toward multi-cloud and what might be the barriers to multi-cloud. And I would also remind all of our audience, both online and here in the studio, this is a roundtable discussion and through a sense. So write down your questions and we'll momentarily start to accept your questions.
David, just a note that John Calhoun has joined us. He is participating voice only, but he is here as well.
Oh, fantastic.
Do you want me to go ahead, or do we want to do the introduction to John Calhoun?
Let's then introduce John Calhoun. If you'll hold the thought for a moment, John Messina. So John Calhoun, thank you for being with us. John is with Microsoft as the Director of Standards and Standards Engagements. And he, like many of our standards developing experts, serves in multiple committees. And he is the ISO IEC JTC1 SC 38 international representative for the global secretariat to JTC1. And so, John, can you tell us about your journey into standards and your participation in particular in the cloud domain? You have your pick of the litter, as they say, as to which standards someone of your stature could be personally involved in, and you've been involved in many, but why do you see cloud as important, and how did you get there?
Yeah, thanks, David. Can you hear me now?
Yes, sir.
Okay, great. Apologies for my tardiness. We're actually experiencing firsthand some of the issues with using cloud services, even, somewhere between 15 and 18 years in, we still have our fair share of issues. I got started in the whole standards thing a long time ago as a technical evangelist at Microsoft, and there was a standard coming along called Card Bay that we didn't understand very well, and we didn't understand how it was going to work with Windows at the time. And my background at that time, I was working on client-side hardware issues. So anyway, I jumped in and went through a very steep learning curve. TCMCIA at that time, had been around for a while. I was a new guy participating with a bunch of people with 20 plus years of experience. So it was that start was real interesting. Cloud was one of these things that through sort of machinations of the standards team that I've been in for a number of years, we ended up getting involved in a number of the legal issues that my company went through, a dozen to 20 years ago. And as cloud computing came along, it became really apparent to us that regulators were going to jump on this technology just based on our, at that time, recent experience. And it's actually taken about another dozen years for that epiphany to come true. But so I was kind of thrown into the whole thing. I at that time, our cloud effort was essentially a group of distinguished engineers that were working 24/7 to take our server sorts of products and put them in the sky and get some services up and running that we could start working with customers on. And so I just jumped into it and learned everything the hard way. And then I started participating in, JTC1 SC 38 on, at that time it was called Distributed Applications and Processes or something like that, and which quickly became dominated by the cloud topics. and I worked on some of those original standards on, terminology and concepts along with John Messina. Worked on SLA, worked on, I don't know, many of the standards that came out of SC38, especially in the early days. And then I ended up becoming project editor on a standard for framework for data sharing agreements, trusted processing of multi-source data, and then also on a revision of a standard for categorization of data, where we did some examples on how to extend and implement the thing. So that was kind of a little bit of rambling around, but I hope I got to the point.
Yes, sir. Yes, we read you loud and clear, and we're very grateful for your participation, for Microsoft's participation, and your colleague Laura Lindsay, who is on a ship right now and couldn't be with us, but we're grateful for her participation too as the chair of INCITS. And we have admiration for your prescience, your foresight of what's happening 10 years down the road. So when we get together in person, I'm going to ask you what's going to happen 10 years from now. Let's turn back to John, the other John Messina from NIST, and we talked about how cloud has really taken off, and how multi-cloud is really the direction that so many are turning to right now. And you had some thoughts as to why that is happening and what might the trade-offs and barriers might be.
Yes, thank you. So NIST itself is not a policy setting organization. We go out there and we help develop new standards, technologies, all to help to grow the US economy. So we don't necessarily have any desire to push one way or the other. We do like public working groups where we interact with academia, government agencies, private industry, all trying to identify issues that they're having that prevents them moving forward. Then we bring our technical expertise together and we bring people to work on it. Through all that activity, I've definitely noticed that there's certain things moving forward that would be best solved, and they typically involve multi-cloud computing, and there are some barriers. Now, I'm going to be speaking from a customer perspective. As one of the other panelists mentioned, there's a difference when you tend to talk about government and private industry. In this case, a lot of the times when we go to the standards organization, we represent the customers because the United States government has a lot of agencies that acquire services in cloud computing. And one of the things we've noticed is that there are a lot of interest and business needs that are pretty much anything can be addressed through cloud computing to one extent or another. But there's some data or problem areas that are better suited to being dealt with in by multi-cloud solutions or situations. And I'm just going to go through a couple of them and list them to give you a sense of why people might be moving towards multi-clouds. For example, big data. You could have huge repositories of data that are simply too large to feasibly move or copy over. So you essentially have to go to where the data is to process it for whatever you're doing. And if that data is stored in one particular cloud service provider, you might have to arrange for your cloud service provider to be able to interact with another cloud service provider to gain access to that data. Universities doing research into medical data are a great example of this. They all do their own particular research. They form webs of organizations where they share data between the universities, but any given university might use one cloud service provider versus another. So we have the environment already where if you're going to be dealing with big data, in a lot of cases, you're already going to be dealing with a multi-cloud environment, which means the data might be in one cloud, or you might have to access services in a different cloud. You have something similar when you're dealing with restricted data. A lot of government data tends to be restricted to the legal jurisdiction of that particular country, for example, the United States. So you have to go to where the data is or the services is if you want to make use of it. That's a particular interest for the United States government as a customer. You have groups of shared interest. You might have a bunch of companies together that want to share data or want to work together, but like I said, in the big data, they all might be using different cloud service providers already. So then the question is how do they integrate them into some sort of a solution so they can share data? There's like one particular company that I know of that actually went out there and they wanted to create a loyalty program for their customers, and they had been using one cloud service provider, but it simply didn't have the information they needed to be able to flesh out a very full and complete loyalty program. So they ended up having to negotiate with their cloud service provider and others so they could incorporate them and create that brand new service available for them. And that typically comes down to what most people see as the major benefit of multi-cloud computing is that if you can combine the resources and services of multiple cloud service providers, you can develop new services that any single cloud service provider might have difficulty providing. Whether it is aggregating data from multiple cloud service providers or doing a value add where you can add on top of the information that you get from other cloud service providers. There are a lot of companies out there developing innovative services, and the cloud service providers certainly want to help them, but they don't always have everything that the customer needs. And being able to go out to other cloud service providers to acquire services and resources allows them to fulfill their customers' needs. One other thing I want to mention is that one of the stumbling blocks for adoption of cloud computing, and I'm not saying this is a true solution, but multi-cloud offers some ability to deal with it. One of the questions customers have when signing up for a cloud service is what happens when the term of service is over. Whether the company goes out of business or you find another company that you want to move to, how do you transmit your data services, whatever, from one cloud service provider to another? Certainly, all cloud service providers in their service level agreements will say, we'll help the customer to the best of our ability to migrate their data. And certainly that has to happen in a lot of situations because some companies reduce their own IT capabilities within their companies in their migration to cloud. So if it's ending, you might not have the ability to bring everything back to the company itself or the organization. You might need to find a new repository somewhere else. If you're dealing in a multi-cloud environment, certain templates that you can use would actually make it easier to migrate from one cloud service provider to another. But that brings to the concept of what are the barriers. I mean, we all do cloud computing fairly well. I mean, obviously, we need to deal with edge conditions. We need to deal with security. Those are all things that we're still dealing with. But one of the things that we need to focus on is how do you get the cloud service providers to interact more fluidly with each other to provide these additional services or to deal with their customers' needs. And a lot of cases, those barriers are simply how to get them to communicate and how to get them um, actively interacting on a technical level. One of the things that we've been doing, and since we're NIST, we tend to look very far out. We tend to do the foundational stuff. If you go to any cloud computing conference or university, government agency, and you ask what multi-cloud is, you're going to get a lot of different answers. It could be multiple clouds interacting with each other within one cloud service provider. You could have clouds interacting with each other from multiple cloud service providers. There's so many different arrangements, how they're organized, how they communicate. So if you go to a conference and you sit through 5 talks, you'd probably come out of there with 7 or 8 different ideas of what multi-cloud actually means. So one of the things we're doing in ISO IEC is we wanted to create a common vocabulary for multi-cloud. The common terms and definitions so that it's not necessarily declaring this is the absolute vocabulary that everybody can use, but this is a vocabulary that you can use to facilitate communication between the cloud service providers and the customers so they can have a meaningful conversation between each other and actually understand what it is everybody wants. And there's a new standard that we're working on in SC 385140, which not only does the vocabulary for multi-clouds, but it also describes the high-level concepts involved in multi-clouds. Another example of a multi-cloud formation that you could do or a template is something called a federated cloud, which is really an organization of cloud service providers to get together and agree on how they're going to exchange and make use of each other's resources and services. That means they can agree to a common lookup format, what APIs they're going to be using to communicate with each other. How do you determine who's a member? How do you get rid of members at the end of a particular service. It is really an additional level on top of cloud computing. But one of the things we can do in multi-cloud, and one of the barriers that we need to address, is that you have cloud computing and now you have multi-cloud on top of it. We have all these additional concerns like user authentication across cloud service providers, identification. How are you going to bill across the cloud service providers? What resources are available to members of the multi-cloud? All those things can easily be, well, maybe not easily, but they can be agreed to within a group of people. And you can create an organization called a federation where all of those are codified in a set of policies. That's a template for cloud computing. You can also have or multi-cloud computing. Then you can have other templates, which would facilitate it if you are just going to be the primary cloud service provider and you want to reach out to one secondary cloud service provider to exchange information. By laying out a vocabulary, terminology, the high-level concepts, we can make certain that people can actually have meaningful conversations. And now we're also working on templates and formats that would facilitate people and companies and stakeholders that want to move into multi-cloud so they know what they can do. And it also sets it up in that, since it's almost it's reference architecture in itself, like we're going to have these major components in this cloud computing or multi-cloud computing. We know that we need to be able to deal with authentication, security, what kind of APIs, and then people can choose best of breeds and stick them into the template or use the ones that they're already familiar with. And it would just speed the creation of multi-cloud environments, solutions, and products. And I really think that's one of the biggest issues, is that everybody wants to move to cloud. We need to lay a common foundation for multi-cloud, and then we can come up with some common templates that would then speed the creation of these multi-cloud solutions that would then benefit the customers.
Can I add to this?
Please.
So I agree with everything you're saying. And let me just add from a commercial perspective with our customers. So we have hundreds of the top 2,000 in the world. Their challenges are multi-cloud, yes, and different regions in the country. And you actually have to be multi-cloud, because if you have an office in Saudi, they have a regulation where all data must reside in Saudi. If you're GDPR compliant, right, over in Europe. So where the data is and which cloud it can be in, like AWS isn't even in Saudi, right? So it's only Oracle today. So you have to be multi-cloud, which is why you would use a software like ours. Interestingly enough, this is some of the logistics that we provide, but there are, and all of those companies have on-prem as well, because there are some workloads that cannot ever go down. If you're doing the trading room floor at Vanguard, AWS is their primary provider, they happen to go down. So that you have to have a backup always to keep real-time operations going. This exchange of data across cloud providers is matrixed with exchanging data across geography. And those rules are something that organizations like NIST and others, you actually have a lot of experience doing, right? Because that's what the federal government does, is exchange things across boundaries. But it's not defined in this world. And it's very interesting. So all of our companies have to report on GDPR violations. What is that? Like, what does that look like? And is it across cloud, and who's responsible? Like there's all these questions. And so it is for sure this idea of clouds, the physical part of the cloud, I guess, but it's also how the data moves in real time and in real life. And it's a very matrix problem. And then, by the way, you mentioned space, which cracks me up because we're dealing with 3 of the commercial space organizations, and that's the wild, wild west. I mean, talk about no standards. There's nothing. I mean, it's crazy, the stuff that's moving back and forth in terms of data. So it's a big problem that needs regulation for sure.
Actually, if I may add, it's not just moving back and forth, but their operating speeds are very different.
Very different.
So yeah, although the requirements are really to have real-time applications, the networks don't work like that.
Yeah,
They are
millisecond.
millisecond, gigabits per second, those things don't exist in space communication.
Yeah.
They are very different standards. And this application of cybersecurity, and you mentioned a couple, John, about authentication and even the storage up there. What standard do you go for? Do you go for like some sort of a database-like standard, or do you go for the extreme of having fully homomorphic encryption on a satellite? Hard to get, but incredibly heavy cryptography, right? So there's a lot of things in the horizon that's coming up, but also it depends on the satellite provider. Some of them will say, but we don't want that one. We don't want this, we want this other one. And they're a global community. You know, LEO satellites are going to be serving every country, every jurisdiction. They could have like internet communication inside their service. And to what degree they have to be compliant or transparent, it itself is an issue.
Yes,
But
yes, exactly.
So how does your organization, Panzura, deal with the latency issue?
Yeah, so we have some inherent technology about, I'm sure most of you know, but I'll just say it again, that if you have a user file, let's just use an architecture drawing of a building. And on-prem, on a server, that's gonna look like an Adobe file, a CAD drawing, something like that. When it's stored in the cloud, it's gonna turn into an object. We take the difference between the two, we create individual blocks, and we only move blocks. And we only move it using kind of AI and ML to the people that need it when they need it. The worst thing that could happen is if you are, I'll stick to that same analogy, you're in the construction industry, you now are out on site and you want to pull up a CAD drawing for this building. Well, it's too big for whatever you have at the edge. And so you have to use some logic as to how you're going to serve up that information so that person can use it. And then they make a change, and let's say the electrician is there and they want to make a change. Who owns the IP on that document now? There needs to be user control. There needs to be an audit trail, all those things that are part of our software. So if that party breaks ways and something's not paid, the electrician keeps their work, everybody keeps their own, and it's all okay. It's very confusing when you talk about real-time trades all over the world and all of this regulatory requirements inside of it, right? And we're left to comply hyperscaler by hyperscaler and country by country. So you can imagine we have all of those developers, all of that QA, all of those people to do it because it doesn't exist, right? So we have to do it. Someday it would be great that some of this was built in, right? I remember the early days of, creating just mobile applications, right? There was no standards. Then all of a sudden we said, okay, here's how it works. And then we didn't have to do it anymore. It was just embedded, so.
Well, you make it look easy. I believe the Italian word is sprezzatura, the art of making the incredibly difficult to appear, effortless.
Yeah.
But certainly, let's think about the other elements in our taxonomy of challenges to reliable, efficient, low latency, secure, multi-cloud or federated cloud computing. Last month we had a roundtable, a very distinguished panel talking about cybersecurity in the era of authoritarian aggression, and certainly our the threat vectors that exist want to take advantage of our cloud infrastructure to weaponize it against us. Would any of the panelists have thoughts about how to how to best, in these new uncertain times, how to best protect that cloud infrastructure from malicious actors.
I have a lot of thoughts, but I don't know if you want me to start. Yeah,
Go ahead.
yeah, so,
You start and then we'll let the
Yeah.
cybersecurity
yeah,
engineering
exactly.
chair
Yeah,
critique your
I'll
response.
tell you, no, well, and I'll tell you the real life and then you add
Okay.
how to fix it, right?
Well,
So I think this is a place where AI and ML could be really helpful and should, by the way, be a requirement on these cloud systems so we can know what's happening in very real time. When things go bad, they go bad quite quickly and at large volumes of data. I mean, large volumes of data. And we see it almost every day now at our customers, some kind of ransomware attack and some internal threats, although that's the lower part of it. And so I do think that there is requirements. There's certainly the protection side, but there also is the visibility side, having the information to know that an attack is under threat. Because I think as fast as we fix the access problem, there's a new threat, right? So we need to know.
Yeah, those things won't end.
No, they won't end.
So I think about 3 or 4 years ago, I was asked on a C-SPAN interview, could we get rid of all the threats and life will be great? My answer to that question was, I repeat it again. To me, that's a dark day because the ingenuity of humankind will stop that day. Sad to say, but that's the truth, as far as I can see. So we will have to be living in an environment in which there are always threat actors. They themselves are quite ingenious. You know, we create some of them too, make them the best in the world. So the question was a little related to are we the best, and in my opinion, we are. But it's an ongoing problem that we just need to be a few steps in front of them. And one of the questions that you answered quite well was, how do you think what would happen in an authoritarian regime? And also you touched on ransomware. One of the challenges there is that if you go for traditional solutions such as duplicate copies, real-time updates, or multi-copies, the attacker themselves could target that very same protocol or technique that you are using and simultaneously infect all of your copies. So we need to be ready. It depends on how much money the attacker has, essentially, because they could look for the best technology, best reverse engineering capability of all the published standards and protocols and run some sort of AI/ML to learn what could possibly be driving technology so good and so quick and so diverse. Could make some guesses of what's known, also what's being worked on, both across academia and the different governments, and a little bit of more of industry than academia, because we like to work on pigeonholed problems. And we are happy when we find a solution, even though that's not the real world solution that people are looking for. To get a great paper, it decreases my H-index. You're supposed to be happy. I know that the academia is coming out of that mindset and meeting industry and government standards in a much more cooperative and a wider sense. But I think to be aware of the problems that you brought out and how far can we think, John, you made a very good point. This is supposed to think very, very far. So I think that is going to be very critical because I should thank NIST. I worked on a lot of virtualization attacks and security at ITF. Those are good.
Simulated attacks.
Or emulated attacks in the lab. Right, we didn't go out for the real infrastructure and also the forensics. It's very, very sophisticated attackers will cover all their tracks. But of course, everyone makes mistakes. Everyone is human. That's exactly what we have to depend on, the fact that even the best attackers are human like us. We have to be looking for their failures. So I think that's, in that sense, it looks like a game. But when you play any game, I guess the best thing to think is that you're going to win. You're going to play to win, not play to lose, right? All these regimes that we're thinking about, they will lose. We have to expect them to be active. We have to get them to be online, thinking far ahead. I think one of the mathematics teachers that I met in Cornell once told me, the best way to compete with someone else is to try to read your own mind and that person's mind before that person does it to you. We just thought was a great way of looking at attacks and defenses and counterattacks, which only the government is authorized to do.
Sounds like your Cornell colleague may have been a chess player. But on the topic of cybersecurity and the distant future and the partnership with NIST, let me ask you about quantum readiness. Is the cloud quantum ready? Because much is made of the new testing of post-quantum encryption algorithms at NIST, as well as the threat that's deemed not to be not so distant in the future of the vulnerability of asymmetric encryption to quantum attack. Is the cloud quantum ready? Is there a multi-cloud or federated cloud aspect of quantum readiness for the cloud? I always come up with at least one stumper during these panels. I invite the audience to do the same. Please, I've got a couple questions here, but make sure you get yours in. We have good time left. But the question on the floor is about quantum readiness.
Unless someone wants to ask, like you said, there are two things, post-quantum and quantum. They're two different things. Post-quantum, I believe the three recommendations that NIST made, we are using those same libraries.
Okay.
That's the lattice-based cryptography. It has a lot of usage. It's heavy, very heavy in the computing infrastructure to do that. So to answer if that's what you want to do in real time, it could be done, but the reason is how much of computing, traditional computing, do we need? Now, I haven't seen a quantum computer. I know that people have that, but that's too expensive for me to get my hands on. Can you put it on a satellite? I'm not sure. There could be people trying that, but with that kind of speed, I'm sure we can do that. But one of the things that most people seem to not pay attention to is that true quantum computing is not based on von Neumann architectures. Right. So
Neumann architectures, right?
The traditional Turing machine type of architecture, going back to my previous education. And then so that in that sense, we need to be more familiar with not only its capabilities and the timing requirements and the power requirements or things like that. Because they draw a lot of power. So if you're going to put it on something that moves a lot, you better be able to move the power too. Then the issue then is that, are we aware of all of the consequences that computational model that goes beyond the Turing machine? Are we exploiting the limitations? If I am paid to attack one of those machines, this is where I would begin. I know I'm not paid to say how to begin attacks, but
Well,
you know, you have to add that.
Yeah.
I should have prefaced that question by, saying, don't share anything that you're not supposed to share, because I hope that different parts of our government are hard at work at this and other questions. So
Absolutely, but we do that in class group all the time. We had to incite the younger generation to be better than us. You know, we always say that, think about how you would beat me at this game. I always tell my students that it's good to create a better generation than the one that brought me up.
well, you raise another interesting concern or challenge about the cloud amidst your discussion of quantum computing, and that's with respect to the power requirements. There was an executive order about sustainability and lots of developments now with respect to moving toward more sustainable standards, both in terms of the for government procurement, in particular with respect to operational carbon footprint, as well as the embodied carbon aspect of cloud data center infrastructure. But just looking at the operational side, I've heard that artificial intelligence, machine learning is responsible for a doubling of electricity usage every 3.5 months. Have you heard that statistic? How do we have, of course, this trajectory won't continue forever, but nonetheless, it's something that's got everyone's attention. And how do we address the challenge of providing multi-cloud cloud services in an environmentally sustainable way?
I have a couple of thoughts that I can mention with regard to it. So one, we've already mentioned edge computing. One of the things that I've seen are a lot of calculations of, does it make sense if you're going to do some sort of calculation on a particular problem, does it make sense to migrate it all the way back to a data center to do the work there? Or can you take advantage of local resources that would then be able to do part or all of it locally, which would then you wouldn't need the additional effort and time to send it all the way to a data center and come back. One of the other added advantage of cloud computing in large data centers is if I'm going to send my calculation off to a data center, you have the freedom of putting the data centers where renewable resources are readily available. You can put it someplace where there's wind power a lot, and then you could design the data center to take advantage of natural wind to cool the data center. Water power generation, you could do a data center nearby. Obviously, what is it? The information that we had when we were kids is like a stream. Now it's like a fire hose, which is probably why you have all the AI and the ML has more and more data that they have to process, and that'll obviously continue up. But if we're smart about choosing data centers and cloud computing, and we take advantage of local resources and put it where we have sustainable, renewable energy supplies, that can offset it at least somewhat.
Very good. Other thoughts on sustainability?
Well, John Calhoun here. I spent a few years in JTC1 SC38, which originally was sustainability by and for IT. And then I recently started working with one of our business units on some emerging policy that's coming around, that's intersecting that work. I think one of the, I think the dimensionality is one of the issues. We use this big word about environmental sustainability, but you really got to decompose that down. Certainly greenhouse gas emissions that contribute to climate change are a big one. Water usage is a big one. Just availability of electricity relative to all of the other users is more of a societal sustainability issue. So you must have to decompose these into different pieces. AI is an extremely compute intensive activity, and there's sort of this reality. I don't want to hurt anybody's feelings, but our current silicon architecture is very good at converting electricity to heat. So we do a lot of things around the periphery of that. In terms of, okay, well, let's get more efficient on the infrastructure side, the cooling side, so we're not using so much electricity just to remove heat from the silicon, and industry's made a lot of progress, in that over the last 10 to 15 years. We still tend to look at, the capacity or the productivity of the IT equipment by its power consumption. And so we've had a hard time saying, look, we need to, for every flip of the gate, we need to figure out how to use fewer electrons to do that, and generate less heat in that process. And that's a very difficult physics problem, and we're probably a ways from solving that. One of the things that we can do a better job of is figuring out metrics. What's the impact on a particular vector versus what are we getting out of it? So for the AI example, for the kilowatt hours that it takes to train a particular model, what are we getting out of that? Well, we don't really actually have a really good measure for that today, but it's really coming to a head. I think it's the London Housing Authority, sent out notifications that they're not going to be able to permit projects over like 25 units because they can't get electricity to them, and they cited the number of data centers popping up in their jurisdiction over the last number of years as one of the reasons. So this is gonna become a more intense discussion, not only around the traditional environmental sustainability things, but around the societal sustainability things. We all need electricity to live our lifestyles, and with electrified transportation coming along, our consumption is going to go up. And to actually bring up the developing world to any sort of living standard comparable to the developed world, our consumption worldwide would actually double per year, and right now I don't think we have a way of actually doing that. So anyway, that was a bunch of little data points I'm kind of interested in, particularly the people who are serving a number of different customers. Do they have any ideas that we're missing out on right now? We're trying to build capacity to meet demand, and that is consuming a lot of electricity. And yes, renewables will help with the greenhouse gas issues, but then it also creates its own set of issues, and we still have water, land, lots of other impacts to deal with.
Thank you, John. Tommy, you want to weigh in?
Yeah, just on the sustainability issue, we're very engaged in sustainability, and one of the uncomfortable facts in this area, particularly with power, is that the most energy dense form of sustainable energy is nuclear power. And some of the work at Oak Ridge in microreactors in a new thought pattern of 6 foot high man-size 1 megawatt reactors, and you just pump them out with a prearranged design so that they're pre-certified before you ever start the build. You could even do them with a 3D printer if you could design the printer right to build the same thing time and time again, it solves the problem of environmentally, or at least climate sustainability, because the nuclear reactor produces no greenhouse gases. Now, it does have some radioactive waste that we spent billions of dollars to build a facility in Nevada to store, and not being used today, and you'd have to get over that hurdle. But those are policy issues. They're not technology issues.
Right, and I understand also there is the downside of when there is an occupying army next to your nuclear reactor, large or small. Happy Ukraine Independence Day, by the way. 24th.
Yeah, but the new design would resolve that. So there'd be,
okay.
you're not going to release the radioactivity in the environment, even if the Army was there and trying to. It's fluidized bed is really the better design. But it brings up the issue for the cloud, which is this panel's discussion of the cost of the cloud.
Yes.
And energy is not free. Nuclear reactors cost as much as a solar plant or a wind plant or oil barrels coming from Saudi Arabia. So there's a pricing that most people, and specifically government agencies, when they move to the cloud, who's calculated the cost? And I think that's driven when you realize, gee, we can't afford this in the limited budget that the Congress gives us. It's driven you to a hybrid solution for a hybrid cloud, because the cost of something in your backyard that you're operating and owning is much different than, putting this hardware out dispersed all over the globe and then trying to do the data transmissions and the cost to move the data, as well as the cost to store the data and another facility at some other company.
Well, there's certainly a parallel, an analogy there between electricity and the movement of data.
Yes.
If you get your power source close to the consumption, you don't have the transport cost that you might have if you have the centralized, exclusively the centralized production of power. But what do you think about the incorporation of mobile edge computing into the cloud infrastructure as a means of improving the latency, but also lowering the energy footprint, and the greenhouse gas footprint, and CO2 operationally, and the embodied CO2, which includes not just CO2 itself, but the CO2 equivalents of molecules that are tens of thousands of times more damaging to the atmosphere, like nitrogen trifluoride, that are used so much in flat panels and in microelectronics. Is this another reason to embrace the vision of 5G mix?
Yes, I think so. So 5G mix do bring a lot of capabilities. There's no doubt about that. But eventually it's a service-based system that is very close to the radio. It's a direct connect rate to the radio and the communication infrastructure. That itself is like any other service. It needs to be maintained. It's like another cloud system, but that may be differently arranged so that you could do quick service. Maybe at some point you had to back up. That is a solution, but that still requires energy. It doesn't relieve us from the burden of having that energy. And there's nothing preventing you from putting a big system as an edge service too. I think as far as I know, there's no limitation for that. It's just that it has to be very close to the radio edge, that it does not have to go through the core of a network, even the 5G, 6G type of networks. So one could argue that it saves energy because you do not use so many virtualized components on the core of the network, but then you also have to maintain this extra thing, right? And it requires the intelligence and how to essentially manage the packets to the edge versus the cloud. But I think if you think that, I would compare it this way. See, we have primary storage on our machine, then we have backup storage, we have thumb drives. Each one has its place. So the cloud itself has its place. So the thumb drive, it's quick. Some organizations prevent you from bringing it. It has its negative sides. It could be rest and then you have no way to recover because of a different memory system. Similarly, the edge services has its quick access capability. But if you try to make that your whole data system, your whole data stack resides there, then what you would end up having is that every radio tower will have its own cloud. And then you have to communicate between them using some other mechanism.
Unless you have an abstraction layer somewhere that can optimize those packets that only will pay the freight for being really close to the customer. And we can hypothesize all day long about what could or might happen, but Jill Stellfox sees quarter to quarter what reality is. Is there any potential integration of the edge and the traditional cloud, multi-cloud?
There has to be.
Has to be.
I mean, yeah, there has to be. Well, all decisions are made at the edge. That's our philosophy. And so you've got to have the data at the edge. And the question, there's two parts to it. Like, what needs to be at the edge? And then where is compute? You know, to what John Messina was saying earlier, where do you put compute? And oftentimes, the device at the edge is a great place to offload some of those decisions. It's also the riskiest in terms of security. Because generally the user at the edge is the one that doesn't pay attention as much. How many of you updated your Apple devices, my friends, right? Like a lot of people, right? But then ask your mom, did she? Absolutely not, right? So it's kind of a funny, funny world, the edge. And it needs a lot of care and not a lot of thinking about how to do it. Yet it's happening every day.
Yeah, actually, Jill, you made a very important point. Is edge security same or different from cloud security?
Totally different.
Yes, it's for usage scenario is very different.
Yeah.
Do we cover it from the same security perspective? Right now, that's an evolving question, right?
Yeah.
And if you want to do basically other kinds of communication, direct edge-to-edge communication, try to bypass the traditional networking and routing, this will bring up a lot of other issues. And among things would be the consistency of the permanent versus temporary storage. We've spent decades fixing that problem.
Yeah, it's actually interesting because that's so we address the edge very much as a disappearing place.
How about here?
Because you have to, I think you have to, there's not enough standards or regulations at the edge, and it's the most likely place of vulnerability. So you have to imagine that in certain moments, it's gonna disappear. And I hate to go back to AI/ML, but it's like my favorite thing. So you can use that to know that somebody's working day is over. If it's over, they don't need it, don't leave it. So this idea that you would leave data on an edge device for bad things to happen, that doesn't need to be part of your way of thinking. So
That really depends on the threat factor.
totally,
There's an argument that the edge is much more secure depending on the platform.
yeah, that's
You know,
true.
This thing right here, I would contend is much more secure than what you would find on the average cloud. And there's reasons because of that, because it's limited, it's segmented. You can determine what the threat vectors are much more easier than you can. And once you get into the cloud, if it's not segmented properly, you've got access to everything. And so it's a risk mitigation pattern that each one has vulnerabilities and each one has to mitigate risk in a different way. Your cell phones are different than the laptop computer. And certainly the database that you have in a data center, that is more closely aligned to what cloud vulnerability is. But you could debate this quite a bit and has been debated for at least a decade.
Yep.
And I don't think there's any there's some facts you can point to but it's not one versus the other. You have to look at each one.
All of them. That's correct. Yeah, I would agree, all of them. And it depends too on the application, right? Where's, does the application provide security at the edge?
And what are you trying to protect? Because if you've got your data encrypted, you know, the risk is that it disappears, not that somebody gathers it and tries to do a brute force hack on your
Yeah,
encryption.
most often it disappears.
Yeah, and that's where the ransomware issue, I think, is the biggest issue today. And it's just as applicable to cloud data as it is to a data center or an individual's data.
Totally agree. And we see them coming in all directions, right? So the attack at the edge and the attack at the cloud. Interesting.
I just got back from Black Hat and DEF CON last week, and I mean, that's scary. When
Scary.
you realize the 25,000 geeks that are there thinking every day how to hack into your systems. And some of them are very, very smart and very ingenious, you know, third and fourth order hacks that are, you know, a chess master couldn't figure out. That's the vulnerability side. And it gets back to the, you know, the best offense is a good defense type analogy in sports. Is you've really got to design systems, both cloud, laptops, phones. You've got to design them with security up front. And it's driving a lot of thinking into redesigning the internet, a quantum internet, because we brought up quantum before, that if you redesign the internet to be secure versus being available or accessible, now you've got something to start with where you have attribution capabilities, where if a hacker tries to break in, you know exactly who it is and where they are and where they live and where their bank accounts are, and you can put a stop to it. Now that's in theory. Practice, there's going to be ways around it.
Yeah.
You know, you're trying to design things for something you're having to project that haven't been invented yet. And so that's where the flexibility comes in.
We spend a lot of our energy on assuming you will suffer ransomware. It's only a matter of time. And it will be from all areas, and it will be multiple times to the same company, sometimes in the same way, because they're buried for a long time. And so we have this thought process around snapshot technology, right? The old Apple time machine idea, right? Got a snapshot, you pull it out, you clean it, you put it back. How fast can that happen for petabytes of data? And
You're looking at it a little differently.
yeah,
We're looking at stopping the ransomware before it gets to the endpoint, to the edge, and through micro segmentation.
Yep.
And through micro virtualization at the endpoint, where any device is 1,000 virtual machines spun up, each one having a different thing, and they're all virtual, so that when you're done with whatever operations you are, any malware that's been downloaded disappears. And it's been, I think our last test was 18 billion attempts on our systems, 0 successes. Somebody's going to figure out how to do it. We can't figure it out. I mean, we kind of hope somebody will figure out the flaw, but you know, until they do, and you know, we're keeping a vigilant eye on how successful this software is. It works for Windows. We haven't ported it to Apple operating systems, but it could be. It's a theory, and we're not the only ones doing it. There's some people doing this up in the cloud. We're doing it at the endpoint because that's what we do. But either way, if you could stop ransomware, that takes a whole threat vector away. And then you don't have to worry about
Yeah. We actually, it's funny, we've been working on just the same thing, Apple's, Windows, iOS, whether it's and cloud, and then multi-cloud. And this is where, by the way, standards would be like, please God, because it is very hard to do across the board. But interestingly enough, we've been running these detections for 8 or 9 months in real time at real customer sites across the globe. And so we identify that there's a problem. You want to know the most fascinating thing? CIOs don't turn it off, because we could turn it off. They want to look at it and watch it and see. Like, who would want to turn off your entire cloud? Well, unfortunately, that's what you have to do. And so what's really interesting that we're seeing is even though we can stop it, they want to watch it. And I just laugh because every time you do that, the physics of putting that data back in a place in which your company could be operating is a long time, hours and sometimes weeks. So you might imagine that there is this urgent 24/7 group of people that we have that are like, wait. And there was a very public one in the UK that I can talk about, a company called Shepherd Robinson, and they got nailed 2 or 3 weeks ago, major issue. And it took them almost a day before they believed. And by then, everything was gone, except they used Panzura. And so we put them back through snapshots. And it's taken, the company was up and working in every region but one in about 2 days. And this last region, we just got it up and it's been like 3 weeks now since the whole thing happened. They have all their data, everyone's working, but somebody else has all their data too. So there's the long-term problem of the whole thing, right?
On the subject of turning it off, I have one more question to pose to the panel that is a little out of left field, but you'll humor me. And then we have a few questions from our online participants, and I'll just read them off and you can respond to them. And I welcome everyone in the room as well to participate in the conversation. So I used to run the engineering standards committee for satellite communications and at a different association. And so I'm aware of some of the concerns, not just with Kessler syndrome and satellites in orbit having cascading fields and this sort of thing, but there's also the so-called possibility of a Carrington event. The Carrington event was in September 1st and 2nd, 1859. The world was hit with a coronal mass ejection, a field of charged particles from the sun that was, we were right in the bullseye of this very large event. There was a similar event in 2012. It just missed the Earth by a week or so because of the orbits and so forth. But in 1859, these are the days of the so-called, Victorian internet, which were the telegraph lines of the day. They caught on fire. They were arcing to the user at the Morse code station. And one estimate I saw was potential damages of a direct hit of such an event could go up to $2.6 trillion in the US alone. And so you wonder, what is the probability of something like this? Well, it's not too high from year to year. It's maybe 1% or 0.7%. The probability goes up with the solar cycle, the 11-year solar cycle, which peaks next time in 2025. So the question is, if such a thing hit the Earth, we had to power everything down, are we modeling for that? Are we preparing for that? Is the cloud ready for a Carrington event?
Are the highways ready with the cars? Probably bigger impact than the cloud. It's scary.
Actually, you made a very good comment. The first thing I was thinking is that what would happen to our power transfer automation? Yeah, all completely based on the internet right now, right? And then that would bring down everything else. We are used to power. We don't have oil backups for everything.
I wonder if NIST has someone working on this that we could talk to. I think the infrastructure is one question. The other is our habits of mind. The state of our supply chain right now is very vulnerable to any. You lose 1,000 transformers. What are you going to do? There are places that won't have electricity for a year. But on the habits of mind, my teenage daughter was asking me, what did people do when they didn't have cell phones? You meet someone at the metro station, they're not there. Well, you call them on the cell phone. What did you used to do? It wouldn't hurt any of us to practice deviceless from time to time, just for preparation of such a thing.
This is looking at the 19 critical infrastructure areas and the black swan events, that is one of those
Okay,
that they look at, and they try to make contingency plans or try to think through what can we do now that might make a difference. And I think they're doing an excellent job, and from what I've seen, but they've been underfunded and
Sure.
they have limited abilities. It's a new agency, it's only 5 years old. And so I think the Congress is aware of the funding issue and is trying to provide more funds to hire more people. Jen Easterly has, I think, got some authorities to hire people at the right level with the right pay that can actually make a difference in these high-tech areas.
well, I'm very glad to know that CISA, that those kinds of questions are in their wheelhouse. I'm sure they were right there with you at the hack or DEF CON conferences and all.
Jen spoke at one meeting, Chris Inglis, the cyber czar, spoke at DEF CON. It was quite an impressive display.
Erica Goldstein and Chris Butera are some of our friends over there. So let's get to a few of our audience questions. First question, how can we get more students engaged in the standards development work for SC 38? I think maybe that would go to one of the Johns that is directly involved, or the professor who's working at the university.
I do have an answer to that, if you'd like me to continue. One of the things that we have in SC 38 is AG1, which is stakeholder engagement. I'm the new chair of it. One of the things we do is we are working on creating educational material concerning the standards and activities that we're doing in SC 38. We are working on developing in-person like seminars and interactions with various geolocations where we talk about our stuff and also identify what it is their concerns to bring it back to SC 38. And one of the things we're doing is we have a spring and fall plenary. And one of the things we're doing moving forward is a lot of times we will co-locate our meetings with the university. So we are going to have outreach events where we invite students to come learn about what we're doing, talk to them and see what they're doing, and definitely reach down and interact with the students at a university level.
And how could
Yeah, in fact, I was gonna say the US is is hosting the SC 38 plenary fall of 2023, and right now we're working with George Washington University to host on their site, and then as part of that have student engagement opportunities. It's highly localized, but that's an instance of the larger picture that John Messina was talking about.
very good.
And in fact, we actually have one in the spring of 2023, which will be in Brisbane, Australia, and it'll be at a university there, and we'll also do student outreach.
I don't know any students who would like to go to Australia. No, seriously, how do people get in touch and send their college students to participate in this sort of thing?
If I may add, the two things that you can do. One is to offer internships to the senior level students, junior, senior students. They can come and work directly with the internship, with the standards bodies. You mentioned one university, GW, also close by. The second thing you can do is that most schools, such as in our department, we have a senior project. It's a year-long project. You can pose a problem, get a group of students to work on it. That's a great way to not only recruit students, but also to bring the real-life problems to the students and instill in them the requirements and the value of standards and how they need to be aware of it. And if they choose to work in that area, they could go there as well.
Very good advice. And if any students would get in touch with INCITS via our website, I'm happy to facilitate communication with the relevant committee, SC 38 or any of the other committees, quantum computing. We also want to bring rising talents into this field, and we try to make that easy to happen now. Before moving on to the next question, I would just add that I printed out an analysis of the recent funding opportunities for universities in the CHIPS and Science Act that ITI was so instrumental in nudging along through the House and the Senate. How many pages was it? It was 19 pages, just respective to the HBCUs. So there's a lot of funding, and in standards education, I heard yesterday from the NIST leadership that there is a clear direction for NIST to expand its standards education activities as well. This is an interesting question about cloud FinOps. With cloud cost control being a challenge for many organizations, I'd love to hear about cloud financial management, also known as cloud FinOps, to the extent any of the participants can speak to that.
We face it every day with our customers. It's one of the reasons to use a software logistics platform, because cloud, I mean, two things about cloud costs that are really hard to manage for CIOs. One is the volume of primary storage increasing from edge, from databases, from everything. And it's a problem, and it increases. We see real-time increases in a low of 14%, high of 60% year over year. So it's growing beyond the ability to manage costs in some ways. And then the second is, are you really managing the data in terms of archive and other things to where you are storing properly what's in the cloud? Have you thought through what's there versus what doesn't need to be there? And if you're archiving data, it is very cheap to do it in the cloud. However, it's also cheap if you have a bunch of servers. So if you have old architecture, put it there. And so there's a lot of interesting things you can do about managing what's where when. The other is, you know, something that John talked about earlier, this multi-cloud federation and being always able to move. Because if you can move, then you can drive costs and that discussion around cost.
You're not in a vendor lock.
Yeah, you're not in vendor lock, and it takes forever to move this data physically from one cloud to another if you don't have some way to do it already, to somehow mirror across or manage it.
So you're talking about putting your data in 3 separate clouds, or okay.
Without having the egress charges each time you move, right?
Right.
And if you use software like ours and others, you can move data. We're a platform that sits above all those clouds, right? And so we can move data across all the clouds without all the egress charges.
Your storage costs to prevent movement cost, and that's a trade-off you have to calculate.
So yes and no, and it depends on how you do it. Yeah, and this is what's interesting, right, about architecting the right infrastructure. And we really focus on doing this based on workloads, right? If it's x-rays out of, you know, in healthcare, what is the right way to think about architecting that solution to manage costs? Because it's a big part of it, manage access, manage regulation, all of it, right? Unfortunately, that's how you have the detail of how you have to think about it, because everything is, you know, it's all so different and there are no standards, please.
The lessons for the standard setting bodies is cost is going to be a big impact on how industry applies the standards, because they're going to figure out the minimum cost sooner or later.
Absolutely.
They will come to a conclusion. And if that's not part of the standard, they'll ignore the standard and go for the minimum cost. So when you're setting the standards, your calculations of cost have to be in there, at least some estimate or analysis has to be done.
Either cost avoidance or cost increase for sure.
Darren, did you want to add something?
Yeah, quick follow-up.
And anyone who wants to identify themselves when they're speaking, you're welcome to do that or not do that. But everybody knows Tommy from HP.
I'm Darren Jones. I'm the Assistant Director for Strategic Technology Policy at the FBI. And you made an interesting comment earlier about homomorphic encryption. I'm curious how far off you think we are from really meaningful, applicable homomorphic encryption. And if we reach that point, does that then drive the commoditization of storage and have massive impact on where your data is located? Because now that becomes a whole lot less relevant. And so I'm curious, how far out do you think that's going to be? And how profound is that going to impact?
I think it will have profound impact. There are some very good examples of working homomorphic encryption systems. But if you come up with your newest application that doesn't look like anything else, then people have to go through the mathematics.
There's been some really good research being done at several universities in quantum memory, which will have a major impact, and a quantum true random number generator, which will help get you a step closer to homomorphic encryption.
Absolutely. And there are 2 free libraries available. Google has one. There's another one at University in New Jersey. We are using the combination of the 2. Most applications, if you use the pieces that you can get from the homomorphic encryption, you can create most applications. We are particularly interested in more communicating systems like the edge and the cloud and so on. They're not that difficult to do. The thing is, that's not a guarantee that you can do everything. Especially if it's a database access, yes, right. Those things are very well researched, and one could get a lot of software support with them.
By the way, I think you're headed in like a really important direction. That in the old world, we could think of data as just data, right? And now it cannot be, because there are some things where security, things like this are going to come available much sooner than others. And you need to move it in the, you know what I'm saying?
Right.
And so we spend more time talking about just that. Let's talk about what it is. They're like, well, we have, 20 petabytes of, 20 petabytes of data we want to move in the next 6 months. Great. What is it? What are you doing? And depending on what you're doing has everything to do with what protocol to use.
Yeah, that's true. So I think the downside of this is that even yesterday I had to point out to somebody because of our involvement in an IUCS. You could get the system to prototype stage. How do you go to FedRAMP and ATO and ATT? This is a different story. That's I guess something related to standardization, but it's mostly for governance.
So Sanana Rawls is the head of the Institute for the Digital Economy at MIT, and he has been working for years in storing data in algorithms, not in zeros and ones. And when you get to that, you're storing an algorithm that can replicate the data if needed or when needed, can really save on data storage costs. And I know the NSA was very, very interested in some of his work. And I think he's developed several apps that you can use today to minimize storage on things like a phone or other endpoints.
On the cost optimization question, does a modern abstraction layer like Panzura, does it use AI and ML to optimize where loads go based on? You're doing that with your AI.
Yeah, I think you have to. Yes. Yes, we do it. And yes, you have to. And it has to be really flexible because minds change. There was a big change at one of the major companies you would all know, and their legal department just decided, well, we're going to keep everything 3 years longer.
Mhm.
Like, oh my God. We all looked at each other and went, do you have any idea what that means in practice? And all of a sudden it's like, right, there goes all the data. But do you really need it? Right? Like how long has it been since somebody's touched it? But what it needs to be is immediately accessible, especially for 3-letter agencies. We have some of those, right? You got to be able to get it when you need it immediately. And so this is where this idea of data logistics and data management has to be part of this discussion about cloud. Because it's not the same. You just throw it on a server and you're good.
Well, on financial results, Reuters did report last week a dip in the outcomes of the major cloud infrastructure providers, all three. And I wonder, was that reflective of the macroeconomic conditions, or is it people getting smart about using the tools available to optimize their load, you know, or the FinOps that we're talking about? Do you have any
Yeah,
guesses?
Yeah, I have guesses is what I would say. I think it's a little bit of both,
Little both.
but it's primarily a lot of budgets being put on pause based on the current economic climate, right? Everyone's holding a little bit, so.
Here's another question for you. Wouldn't a distributed application model greatly simplify the cloud and multi-cloud model? I'm not sure. I'll defer to the experts on what they mean by a multi-cloud, distributed application model. Not being a software developer myself.
Well, so multi-cloud systems are distributed clouds. The way they are arranged is if it's one-to-one, one-to-many, or it's federated, or it's in a cluster. That depends on the interface you give to the outside. And also the application, is it inherently distributed, or it needs to be distributed by the cloud provider? Some applications, some algorithms are embarrassingly distributed. They have very little, the distributed copies that run share very little. Those are very easy to put on distributed systems. But if you're talking about the cloud itself, this is storage plus computation, right? If your computation model was developed as a distributed computing, yes. If it was not, if it's a monolithic computing system that you expect the cloud to distribute, this is like the old problem of, can you take every algorithm and make it distributed? The question is that, is the communication cost and the cost to re-engineer, is it worthwhile going through the essential application and tearing it apart? Sometimes it is, sometimes it's not. Like some of the applications that you mentioned about X-rays and so on, those could be easily distributed.
Yeah.
You could, that's what you do in load distribution, right? But if it's not inherently distributed, a good example is so badly sequentialized, then there's nothing to do.
Your answer suggests that maybe there should be a specific step, a specific box to check in any new architecture team's development that they need to take into account this evolving infrastructure and and whether their class of application or service needs to take advantage of the opportunity.
Yes, true. Sometimes actually distribution happens because you think of something else. A good example is failure tolerance. When you build a real life application, you always think of what happens if this site goes down, what happens if this server doesn't work, or it encounters a delay. So most of the airline and mass transit scheduling systems, those are distributed to begin with because they expect something to go down. And it's very, very rare that there's a physical breakdown that you can't capture in that pre-analysis of safety versus faults. Those are very good examples that run on cloud systems, and they occasionally hit the physical barrier. You saw the tunnel problem in the Eurotunnel. That's a physical fault. That's not a protocol fault. Although the train control system is fully distributed, there's nothing you can do if one of them gets stuck in a tunnel. So that analysis is usually very mature, and that could be brought into the cloud based on how you thought of. Sometimes it's direct distributed, sometimes it's, yeah, but to address this failure tolerance, we have to make it distributed. And then of course there is the replica management or the state maintenance. If it's distributed, then your application's next stage depends on the global state. You spend all that energy getting this distributed snapshot to be as accurate as possible. Given that there are negative results, that you can't do it perfect.
Thank you. Are there questions in the room? We have a question online about blockchain. Are there questions in the room to?
Oh, yeah, Mike Lasky with Fidelity. If I could ask the panel to sort of cast a crystal ball, say, 10 years out, you know, cloud writ large is so different than we have all been living with. It's virtually unlimited storage now, unlimited processing power, but it's now highly constrained by connectivity, hundreds of jurisdictional issues, IP, copyright, taxation, state actors, positive and negative. How does cloud, which is relatively new, evolve over the next decade, because it is so fundamentally different than those of us with gray hair have seen over the last 40 years. So thoughts on what happens next?
You can take that first.
I was thinking maybe John from NIST, where he sees it going too. I would be interested in hearing that. I'll give you my opinion. So I do think, I mean, the world that we live in today, for the most part, we are taking, I always say old school, but current technologies and putting them in the cloud, current databases, putting them in the cloud, current applications, putting them in the cloud, and they're not built for purpose necessarily. I do think that there's a whole wave of built for purpose things that will be more effective in dealing in this new world and make it easier for specific companies. But I do think companies today are on their own to figure that out. There's no, in the next 10 years, I think we can begin to make the infrastructure of cloud standard. Like, how do we move between hyperscalers information and who owns what when, and what if something goes down on the fly, and how do you manage costs across it, and billing, like all those things might work out. But how an individual company is going to manage their data in the cloud one way or another, I think it's up to the company. One thing I would love to see is some standards around vertical markets and important workloads, because a trading floor is a trading floor is a trading floor, or a, you know, in healthcare, changing X-ray documents is the same, right? There's some stuff.
Not regulatory.
No, not regulatory. I agree.
Your trading floor in UK or Singapore or Beijing is very different than,
Very
so
different.
that's where I was interested in.
Yeah, no, I think it's very different. I don't think that comes together at all. I think all those world boundaries or the metric of all of those regulations, both geography and regulatory within a specific industry, that doesn't change. I think you have to figure out how to deal with it.
So if that's what you had in mind, I thought then you had to get so much of meta. Like if you have two very different trading flows, you want to create a common framework, you need to abstract out that metadata. And based on that, if you can create something like XML schema that you call dynamically and say, in this one, I only do this, but in this other country, I can do that. That would work well. But also, I think in the next 10 years, it might, if I to make a wild guess, it will be like your watch making wanted or unwanted predictions. Stand now, walk around, you need to do this. Because, okay, I need this service now, it will bring it to the edge. And there will be standards that are going across these boundaries, provided if we don't tear apart each other, then there will be these standards and protocols that will bring it to where you are. and have a staged, like, whether it's terrestrial or extraterrestrial, primary, secondary, tertiary storage like things. So like I can give an analogy. When operating systems first came back, they didn't have virtual memory, nothing, right? It's just direct memory. You have to write and you have to read. Then we had that memory hierarchy that came along inside the machine. And then we went to distribute like mainframes. We thought they were bad. We came back. We realized that's also not very good. Then we went back. What with the second time around, this mainframe type of computing was the cloud, and it brought dynamism, right? You could get it wherever you want it. If you forget something at home, like your laptop, this doesn't matter. In fact, you can see I don't have a laptop. I didn't bring anything here because most of the things are on Dropbox or some cloud service. So, but then it doesn't know what we need, what I need right now, right here. If that intelligence based from companies like you, then that would be a more fluid internet. That'd be a more fluid, I don't know what we'll call it, cloud or something else. It's so much of abstraction layers that are built on it that make this fluidity work securely and hopefully providing privacy without tracking people's movements.
So I heard you wanted to hear my opinion there, Jill.
do.
So I think we are in the middle of two massively competing different forces. Cloud computing was once described as a world without borders. You could set up data centers anywhere, you could move data around, but we are building walls around everyone, GDPR and countries with their own national security issues. That original vision of a world without borders doesn't seem to be there. So you have all those separating areas. At the same time, if you look at how telephones evolved over time, you would have the big telecommunications, but you'd have to hand off. Back in the old days, you'd have to call the operator and they would connect you. You could get across the world, but now you just pick up your phone and you dial anybody and you can reach them in the world. So you have the other competing set where it's making cloud computing just a basic infrastructure, and you'll have the associated standards that groups will develop that will facilitate that free motion of services. So it really is a basic infrastructure. I honestly don't know who's going to win, but I'm betting on the standards.
And thank you.
I think, one of the things that, of course, Europe is always the big font of forward-looking regulation, but we have the Data Governance Act, the Data Act, Data Markets Act, Data Services Act, all coming along and undergoing a lot of scrutiny and comment and potential change, but we're going to have to. Business as usual is probably not going to be usual as we start having to implement against those upcoming regulations, and there's bipartisan efforts in the U.S. to do similar things to create more competition in the market and resolve some of the social issues, and there's regulation in India coming out. I don't think that we'll be able to just extend on our current technologies and be able to meet all those regulations. It would be nice if we could. It would be much cheaper for us and quicker to do that. But we haven't within the cloud industry managed to replicate what telcos managed to do over 100 and some years of being able to complete a call and bill for it, between jurisdictions. So we have that ahead of us, along with all of the other issues that have been described during this call around, security, managing the data, privacy is its own tangle of regulations and practices. So we have a whole bunch of things right in front of us that will probably define a lot what we look like from both a business aspect and a technical aspect in 10 years. We have a whole lot of stuff just to deal with what we know about today, along with whatever interesting things people decide to invent and throw on our path in the next decade.
Well, Mike, I think that was an excellent question to end on. We appreciate your question, and as well, we appreciate the important work that we know Widelity is involved in developing the infrastructure over this period of time, 5-10 years, modernizing the infrastructure in the United States. And so one wants to develop the modern infrastructure when we're rebuilding things. I'd like to thank, join me in thanking all of our panelists for ably answering all these questions. And so round of applause, please. Per tradition, the remote participants get a handshake when I next meet them at NIST, perhaps in Boulder, Colorado, when we have our executive board meeting there. John Messina, thank you very much to your team for hosting us out in Denver. But in studio here, we as a small memento of our day together, we'd like to present you both with a quantum secure analog information storage appliance. Unhackable. Thank you. Thank you. AKA a notebook if you can't see it. Well, yes, time flies, doesn't it? So with that, we'll end and adjourn to the rooftop. Thank you.